Welcome to helpyourmath.com. In this video, we're going to do problem 8 in the MAT206.5 final review. In this problem, what we have to do is use completing the square. So we see the instruction says, by completing the square, identify the vertex and the axis of symmetry of the function of f of x equals 3x squared minus 12x plus 14. So in this case, what we're going to have to do is use the completing the square method. To do that, we take our function, which is f of x equals 3x squared minus 12x plus 14. Now to do this, what we have to do is we first have to isolate our x squared term. And we're going to isolate first our 2x terms and separate our 14. So I'm going to take the first step just to show we're taking this apart from everything else with the constant. The second step is then to get rid of the constant that's next to our x squared. So we're going to factor out the greatest common factor of the x squared. We don't care so much what the common factor of the 12x's are. We just want to get this x squared to be 1x squared. So we're going to factor out the 3 of this. And what's left over is we divide both of these terms by 3. In this case, 3x squared divided by 3 is just x squared. And negative 12x is divided by 3 gives us negative 4x's. The next step is pretty straightforward, and you have to hold on to what I'm saying here because it's really important that you follow this procedure. So we want to add and subtract the perfect square that combines with this to create a perfect square in here. So what we're going to do is we're going to take this 3, we'll leave it there. We take x squared minus 4x's, and we're going to add and subtract the term that's half of this middle term's coefficient. Now, what's half of negative 4 is the question. Half of negative 4 is negative 2. We're going to square that, and we're going to add and subtract this perfect square of negative 2, because when we add and subtract it, it equals 0. So we're technically not doing anything to the problem here. What we are doing is completing the square. The next step then is to get rid of the term we don't need. The negative term is always going to come out of here because when we have a perfect square, the last term is always positive. So we're going to factor out this negative, and when we factor this out, we're going to multiply by the 3 that's outside because this is not without being multiplied with 3. So we get 3 parenthesis x squared minus 4x's plus negative 2 squared, parenthesis close. This is coming out, so when it comes out, it has to be multiplied by the 3. So this becomes a negative 3. And we have still the negative 2 squared plus 14. And now what we're going to do is evaluate what we can. However, in here, we're not going to evaluate everything. You're not going to square this. What you're going to do is actually take this 3. You're going to just place the x of this and the negative 2 from inside this perfect square. Then you're going to square this inside the parentheses, because when you expand this, you get exactly what this value gives you. As far as everything else goes, you can start evaluating. So this negative 3, negative 2 squared plus 14, we can kick off. So here we have 3 parenthesis x minus 2 squared, negative 3 times negative 2 squared. We're going to follow the rule of operations. Negative 2 squared is actually 4, so we have 3 by 4 plus 14. And we can further evaluate this to get the completed square, which is the standard form of this equation. So we have 3x minus 2 squared. Negative 3 by 4 is negative 12 plus 14. And this we could evaluate further by combining these like terms. So here we get 3x squared, x not squared, minus 2 parenthesis squared plus 2. So here we have our standard form of the equation. So we could transform this equation into 3 parenthesis x minus 2 squared plus 2. And here we have our standard form of the equation. And in this equation, we have both the vertex and the axis symmetry. So to determine that, what we have to do is determine what our h and k are. And what I'll do here is I'll show you the standard form of the equation. Here's the standard form of a quadratic equation. And what we're going to do is then place this function directly under it so we could understand exactly what this means. So here, based on this, we know if we set this equal to this, we can determine what h is. So x minus h equals x minus 2. We subtract x to both sides. And these go away, these go away. We have negative h equals negative 2. We divide by negative 1, we can solve for our h. And h here becomes just 2. And our k is what it is. we could just say k equals 2. And here we have our vertex then. Our vertex then is going to be 2, 2, because our vertex is h and k. Our vertex point is then 2, 2. And now as far as our axis of symmetry, this is a really basic component. Once you get here, we know that our axis of symmetry is based on the x value of the vertex. So our axis of symmetry is simply x equals 2. Thank you.